Okay, today we're looking at section 5.4, this should say. Section 5.4, dealing with point slope form. And hopefully by the end of the lesson you can say I can write a linear equation using point slope form, and I can graph a linear equation using in point slope form. So, first of all, what is point slope form? So, point slope form is going to look a little bit different to us. However, as we start using it, it does become a little more friendly to us. So here it says point slope form of an equation with non-vertical line with the slope of m going through the point x1, y1 is as follows. You can see what it says here. So this y1, as you can see down below here, represents your y coordinate, and your x1 represents your x coordinate. And once again, your m is your slope. So this would be a great thing to have on a note card, or in your notebook, I should say. So let's take a look at these problems, and we'll see what we can do here. So let me see if I can get to a I'm going to slide that over just a little bit. Okay. So on the bottom here, it says write an equation in point slope form. The line that passes through the given point has given slope. So if we take a look up here at this part right here, we can see what we're going to need to do. So we're going to have a y minus the y value. Well, what is the y value? The y value, or the y coordinate, is a 3. And it says equals. The m is the 5, and it's going to be an x minus the x coordinate. What's the x coordinate? X coordinate is right here, so it's an x minus a 1. So that would be your equation in point slope form, and you would be done. Okay, next one. If we take a look at this one, it would be y minus a negative 1, since this is your y coordinate, equals a negative 3, which is your slope, and then an x minus the x coordinate. So the only thing I would do now is I clean it up because we have double signs. So I'd say y plus 1 equals negative 3 x plus 2. So that would be your equation in point slope form for that one. So I'll give you a little chance to try and write number 3, and then we can see if we get it right. So if you need to pause it, go ahead and pause it. So your equation would have been y plus 7 equals a negative 1/4 x minus a 4. So some of you may be asking, why did I put a plus here? Because we would have had minus a negative 7. Y minus a negative 7 is the same thing as y plus 7. Okay, next thing. If you want to go ahead and try and write the equations for those first two, is that the same thing we just got done doing? Yes, it is. So you don't need to bother doing that. Okay. The bottom part of the slide then says graph the line that passes through the given point and has the given slope. So how do I do that? Well, I know for sure this point is going to be on line -1, -3. So I start with my point, and then I think back to what the slope is telling us. If the slope is 2, that's like a rise of 2, a run of 1. So I simply go up 1, or excuse me, up 2 over 1, up 2 over 1, up 2 over 1. So that forms this line right here. Okay, same idea with this other one. It starts at a -2/6. That's where I'm going to put my first point. And then a -1/2 means I'm going to go down 1 over 2. Down 1 over 2. Down 1 over 2. So I end up with this line. Okay. So if I'm going to graph this equation, we're going to think the same thing. Think of a slope and think of the point that came out of this equation. So the slope is easy. That's 3. Okay. So the x-coordinate. Well, since it's minus a 2 back here, I know my x-coordinate is going to be a 2. Since it says a plus 1, that means it must have been a -1 for a y-coordinate. So again, you do the same thing we were just doing. 2, -1 is your point. Slope of 3 means you're going to go up 3 and over 1. Up 3 and over 1. So I'd end up with this line right here. Okay, same idea on this next one. So I've got a slope of a -1. My coordinates, if I have a +2, I know that must have been a -2. And if I've got a -4, that was a +4. So I've got a -2, +4, slope of a -1. Well, that's like a -1 over 1. So I'm going to go down 1 and over 1, down 1 and over 1, down 1 over 1. So I end up with this line right here. Okay, so the last thing that you're going to see problems like this where you're given 2 points and you need to write it in point slope form and then rewrite it into slope intercept form. So the first thing, point slope form, you're going to need a slope. So how do we find the slope again? Well, from a 1 to a 2, I know I went up 1. From a 5 to a 0, I know I decreased 5. So that's a -5. So it would be a -1/5 for a slope. So now, all we have to do now, we just have to pick one of these two. So I'll pick this one, and then it would be plugging it back into the equation. So y minus 2 equals a -1/5 x minus 0. So now how do I rewrite that into slope-intercept form? Well, slope-intercept form should end up with y equals. So all I have to do is get the y by itself. So I'm going to distribute, which would be a -1/5 x times 0 would be +0. So I have this. So then to get the y all by itself, I simply add 2, and I'm left with y equals a -1/5 x plus 2. Okay, so let's take a look at this next one. Hopefully you have an idea in mind. You know, you're going to have to find the slope. So from a -3 to a 3, or if you want to think of it as 3 minus -3, that's going to be a 6 for your change on your top. If you want to think of it subtracting wise, it'd be 4 minus -2. Or from a -2 to a 4 is a change of 6. So I get a slope of a 1. So now you got to pick one of your points. I'll pick this one this time. So I'm going to plug those two along with my slope back into point slope form. So it'd be y plus a 3 equals a 1 times an x plus a 2. So now, how do I go from there? I want to get into the equation y equals, so I'm going to have to distribute. So I'd have 1x plus 2. So all I have to do to finish it off, subtract the 3, and you end up with a 1x minus a 1. So there would be your equation in slope-intercept form. So hopefully this makes sense. Again, come with questions tomorrow if you are not quite sure. Okay, and that is a wrap.